G'day, my name is Dan Hunter and welcome to session 3 of making Frogger using Gamemaker. Now in this little tutorial we're going to look at a bunch of objects that I have called floaters. Let's look at the aims of the session. Right, what we're going to do is we're going to look at explaining the advantages of object-oriented programming, or OOP. By the end of this session, you should be able to explain the use of inheritance in the OOP context, identify where we could use inheritance in the game of Frogger, identify shared methods and attributes, describe an algorithm for one of our objects, and then we're going to flip over to Gamemaker and look at creating a parent object, creating the child object, and targeting the instance of these objects. So let's remind ourselves about object-oriented programming, or OOP. Object-oriented approach to design provides a method of breaking down complex problems. In games design, it enables to look at complex processes behind the games and break them down into many smaller elements. Once these objects have been identified, we can then identify each object's attributes and their method. Remember, their method is how those objects behave in the game. Let's just identify a few of the objects in the game of Frogger. First one is definitely the frog itself. The player is an object. It's got attributes of X and Y, its position on the screen, and it moves around the screen. That's just one simple method. We've got the cars on the screen. They're an object. We've got the turtles, we've got the logs, and we've got the score. This is not an exhaustive list, but is used to illustrate the types of objects found within simple games design. Okay, let's focus on the road. Now on the road, there's the tractors, cars and trucks. They all share similar attributes and methods. Their sprites may be different, but when it comes down to it, they're kind of the same. Over on the left-hand side, I've listed the attributes of the cars, the tractors and the trucks. They all have an X and Y, their position on the screen. They have a speed and they have a direction. In terms of their methods, they spawn, they're created, they move as the game is playing, and on contact with the frog, they kill the frog. They also screen wrap, so when they appear at the edge of the screen, they also appear on the opposing side of the screen, so they wrap around. Let's have a look at the river now. There's logs and turtles. They also share similar attributes and methods. They have an X and Y, a speed and direction. Like the vehicles, they spawn, they move. They also screen wrap, but this is where they differ. On collision with the frog, they don't kill the frog, they move the frog. But what we can do is, instead of creating them as separate objects, i.e. logs and turtles, we could create one object, one parent object that has the similar attributes. And then we can create off spawn where there's a slight difference. Let's have a look at doing that. Right, we're going to concentrate on the turtles, or more specifically, a floating object. The floating object is always moving. Its X value is always changing. We want to create an algorithm for the frog to be able to stick with the floating object. Breaking it down, or decomposing this problem to its most basic component, is when the collision occurs, we want the X coordinate of the frog to be exactly the same X coordinate, the X position on the screen, as the floater. Really simple algorithm. Frog.x equals floater.x. The X coordination of the frog is the same X as the floater. It really is that simple. So let's have a look at doing that now in Gamemaker.
Okay, let's switch to Gamemaker and let's look at creating our floating object. So very quickly, I'm going to create a brand new sprite for this. SPR floater. Edit sprite, brand new sprite, make it the same size as everything else, 64 and 64. Open that up. Not going to do anything fancy, just going to make it a big purple block. There you go. Save the changes and just tick on that. There we go. And change the center point. Okay, let's create the object of floater. So obj floater, add the sprite to it, purple block, there we go. And I'm going to use the click and drag actions over on the right hand side. So when I create this floater, we're going to make the floater move. Now, just for prototyping, if I can, for speed use, I use the click and drag objects. So what I'm going to do is I'm going to move this. When this object is created, I'm going to start moving something in a direction. This radio button is really interesting because when this object is created, what am I going to do? I'm going to move an object. Which object? The radio button is self, so I'm going to move itself. But you could say, well, when the floater is created, move another object, and you could call it by name. There you go. Or you could move another object, and I'll talk about an other object later. That's going to be really important, so don't forget that. So when this object is created, what I want to do, I want to say, do this to itself. What do I want to do? I want to move left to right, right to left, sorry. I'm going to move this at speed of 3 and then click on OK. What I'm also going to do is I'm going to add another action, and this one is when it intersects with the boundary. I'm going to make sure it's screen maps, wrap horizontal when outside. Again, notice, look, this says, which object does this apply to? We're saying self, but we could apply it to other objects, either by name or using the overall name other. We'll talk about that a little bit later. Okay, let's plonk this on a room and do some very small unit testing. Let's throw the object on there. So big, no, not pad, object floater. Let's put it there. Let's move it down. There we go. Let's just move him there, just for the sake of it. And hit play. So doing my little test, because I've already predefined these objects in my design document, when the game starts, is my object floater there? Yes, it does. Does it move initially? Yes, it does. And secondly, does it screen map? Yes, it does. When I walk on it, nothing happens at this moment. Yeah, because I haven't built that functionality in. So there's my unit testing. There's my test plan done. Brilliant. What I'm going to do is just save this. And this was version 2. This is now version 3 of my prototype because I've added more functionality. Yep, let's overwrite it. Okay, so we looked at the algorithm in PowerPoint, and I'm going to approach it from the frog this time. I'm going to say when the frog collides with object floater, what am I going to do? I'm going to actually just write a bit of code for this. So switch to the code. Nice and simple. Put in some comments because comments are good. Make frog x equals floater x. I'm making a note to myself that what this does is this basically updates the x coordinate of my frog to be the exact same coordinate as my floater. Nice and easy. Obj frog is the name of it. .x, which is the attribute or the variable within that, equals obj underscore floater .x. So just make the x attribute of my frog object the same as the x attribute of my floater. There we go. So let's test it. So now I've added this. When I collide with it, the frog should move with the floater. Wait for it to come back. Here it is. There you go, he's on there. Now I have to align it up, but it is still working. Let's see if I come off. Yeah. Brilliant. Okay. So now what we need to do is we need to test it and go, okay, it works for one object. Does it work for multiple objects? So let's go to my room. Let's go to object floater. And let's just put a couple more in. Let's just space them out because I know what's going to happen because I've done this before. Okay. Let's save this. Let's play it. So testing it, do my objects appear? Yes. Do they wrap? Yes. They've picked up the properties of them all. Fantastic. Okay. So I jump on one. Look, I'm stuck on it. Brilliant. Let's jump to the second one. So let's wait for it to come up. Wait, I've moved. What did that happen? The moment it touched me, I moved. So something's gone wrong there. So let's do that again so you can see it. Let's wait. I touched the frog. That's why. Ready? Okay, I touched that pink one and I'm moving around. What's actually happening is when it interacts, I'm picking up the X coordinate of my original object. Yeah, my original object wasn't there, so it just disappeared off the screen. If I stick, my original object works, but the other one, it goes, well, the X of the frog equals the X of my floater. But it's defaulting to the original floater. So how do I fix that? Well, this is really, really easy to fix. Go to the code, go to object floater. And this is what's happening here. It's picking up the X coordinate of my original floating object. What I want is I want it to be the object of the one that it's colliding with. So not the original one, but the instance of object floater. To get it to interact with the instance of the one I collide with, I use the word other. Remember that from the radio button before? You can either say do it to do the action to itself or an object by name, or there was the option for other. And that's where this comes in. It's orange. It's a reserved word. You can hit F1 and look up other in index and it'll explain everything. Don't just search Google. Okay, have a look at the actual text that goes with it. Well worth looking at. So what I'm doing here is the X coordinate of my frog now equals the X coordinate of the other object I'm touching. And that should now work. Drum roll, please. There's the drum roll. Okay. Hey! 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 Okay, I've got to get it to a line, but in practice, my code is working. Excellent. Oh, I'm so happy. I knew that would work. Okay, so I am now going to quickly show you the inheritance. Basically, I've created a floater, which is the basics of my turtle and my log. So let's very quickly, let's create a sprite, SPR log. Okay, edit sprite, new. Oh, there you go. This. Let's fill it up and make a loggish color. Yeah, that's kind of loggish. It's not, but we'll go for that. There we go. Right. Okay. I'm going to create an object now, and this is obj log. Now, use the same. So nothing new here. Now, I am not going to create any events or actions for this. Instead, I'm going to say this behaves exactly as the parent object. And here, I'm going to select the parent object. I'm going to say this is a floater. So it's a type of floater straight away. So by ticking that, this object log has picked up the same properties and methods as my floater. Let's put it on the page. Let's put another one and put it there. Okay, so let's hit play. See, I didn't put any of the actions in. They're wrapping around and they're creating. Let's see if I jump on it. It's got the same properties and attributes. So what I'm going to do now is I'm going to do something slightly different. I'm going to change this. So like any child, it's going to have some of the attributes of the parents, but it's going to do something a wee bit different. And what I'm going to do is, yes, it's picking up all of the properties, the methods of the floater. But this time, when this gets created, I'm going to change the direction. Let's make it a bit quicker. So change direction. So it's overwriting its genes from before. So it's still got inheritance for everything else. Still got the wrapping. But look, see, it's moving the other direction if I jump on it. So I've just saved myself. I've found the commonality in my objects. I've created a parent object and I've created children objects. And it's made me create the other objects really, really quickly. It's made me work smarter rather than harder. Let's leave it there for Gamemaker and flip back to PowerPoint.
So just to reflect on what we've done, we've explained the advantages of OOPS, object-oriented programming. Basically, it's a way of breaking down complex problems into simple objects, identifying their attributes and their methods. We can use inheritance in an OOP context. We can make a parent object, and the children object off that inherit the methods and the attributes. We can then tweak the methods and the attributes of the children. We've identified where we could use inheritance in the game of the Frogger. We've looked at vehicles and the floating objects. They share similarities, so we could even create a shared object of movable objects. The difference in their children is one kills the frog and one moves the frog. So we've identified the shared methods and attributes there. We've described the algorithm for object floaters. And then we switched over to Gamemaker and we looked at how very easy it is to create a parent object, in this case object floater. We created child objects and then we targeted the instance of those objects by using the name or the other term. Hope you've enjoyed this session. My name has been Dan Hunter and this has been my little session on making Frogger, looking specifically at our floaters. Thanks very much for watching. Bye bye.